Let's talk on circuit breaker. So in the microservice architecture, when we are deployed multiple microservice, and one microservice might be depend on another microservice, and due to the dependency of the chain of microservices. Okay, so there is a one scenario use case where in the microservice environment might be case uh, uh, one or couple of services maybe not responding or maybe responding very slow or maybe some failure. So like here, this is another microservice, lots of microservices. Let's we have multiple microservices. Okay, multiple microservices. So let's client uh, send request. This microservice may call this microservice, they call this microservice, they can they'll call this. So what happened? This microservice, let's assume, are responding very slow, or maybe not responding. So all the calls here come, go to the here. All call come, go to the here, go to the here. As each and every one going to try to, but might be this particular microservice is not in a position or not in a healthy state, and might be shut down, might be very slow, might be not responding. So here the lots of load requests come, and this machines also going to very high because they have to hold, they have to again try, they are going to the wait for, but the request is continuous coming, request is continuous coming. The due to the this failure might be this system also going to the very slow responsive. Due to that might be after a couple of times this microservice also going to the will very slow responsiveness. So in the interconnected microservice, the cause of one specific microservice which is not healthy or not responding or very high latency something. So due to that, another microservice are getting overburden load, and due to that they are also become unhealthy state. Due to that, another microservice also become a problem. So circuit breaker is a one approach, a design pattern which help us how we can avoid this cascading failure. This is known as a cascading failure. Due to the one node problem, another node also affected. Due to this node, another node also affected. This node, another node also affected. So this is known as a cascading failure. So circuit breaker is a kind of a technique or the approach, the way we can address to solve some level of cascading failure. So let's talk about this definition of this circuit breaker. So as you know, circuit breaker is a design pattern used in the distributed development, and to detect when a service or component is not responding or experiencing very high latency, or very slow, you can say. So in this case, circuit breaker, what to prevent the further requests from being sent to it until it's become available for again. So somehow they are circuit breaker design patterns are ensuring that say if this node particular is unhealthy and not responding, then don't forward all request to here. Unnecessary all requests are going to wait, right? So is there any way the circuit breaker provided a way where we can ensure that when you can make a call or wait until this specific servers is not up to date. Okay, so if you talk about the, so it's also ensure that it prevent the cascade failure in the distributed system. So in the microservice environments, these patterns, you can say, help us ensure that, hey, we are not going to uh, allow multiple services, a multiple distributed component and microservices are going to the halt, are very responsive, are unhealthy state due to the one specific microservice failure or unresponsiveness or some problems. Okay, so the terminology here, circuit breaker, you can say, is a come. This terminology is a circuit breaker. Come from your electrical circuit breaker. Whenever in our daily house, in the electricity, in our house, in our buildings, our electrical engineers a system to provide such kind of circuit breaker in our house to prevent the damage from the power of UTs. Let's key you have a house couple of rooms available, a particular couple of rooms. So might be thus powers is supplied to every rooms or every offices, right? So what happen if, let's say, this a house or this building have some problem outage, then due to this fault, due to this fault, they are propagated, this become also become faulty, this become also become faulty, this become also become faulty, and you can say whole complete our building or house going to disturb are going to the outage, power outage, due to the one small failure or problem or shortage in one particular component or particular office or home. So what the electrical engineers say, they are apply some here circuit breaker. If something fault here, the supply which going from this room are going to the cut somehow, so no supply power going to this area, and there is a other system are working as expected. That means key the switches of circuit breaker of particular component house is going to the down, so no power supply going to there, and the failure, once failure is find out, recover everything fix, and after that again you can on the circuit, then again electric flow is going on properly. So the same concept which generally nowadays in your house, even in the room wise, if each room have a some circuit breaker, each room have a circuit breaker. Let's see in each room some fault happen, some fault. So your room, particular circuits are going to the switch down, so that no power supply, only one room no power supply come, and all other your buildings, all other rooms is still going on. Even more are the house level, complete house. Let's see, particular your house have a some problem. So nowadays, the whenever power supply come from the your main gate or main entry level, also there are some circuit. Whole buildings, your power supply going off, but other houses, other building is still lights or electricity is still supplying on. So the same concept, the way in our electric uh, systems we have implemented to the circuit. That means keep the particular region, a particular house, particular building, we have to stop the power supply, so that this problem is not going to propagate to the everywhere. If we are not propagating, this failure are going to cascade it to the complete your house. So the same concept we can you can say think in this our system designs in the distributed microservice environments. Lots of microservices are interconnected, and if one microservices have some problem, some fault, so we have to going to stop the request goes to the that failure or fault node. Once those particular failure or fault nodes are recover or repair, and after that we again start, hey, let's go and going to serve the request. So these are the some basic concept on which parameter base we are systems are going to decide, hey, let's allow the request go to the particular fault node, or we have to wait. So somehow we have to calculate some threshold value. The circuit breaker has a concept of a threshold value that determine when to stop sending requests to the services. So hey, this is the request going to the, this is the microservice X and microservice Y. Okay, so so let's keep, when we decide, hey, this request, if something problem happen, then we have to stop this request, and once this problem recover happen, then we are going to allow to receive the request on this microservice. So we need some kind of a parameter or some number or some conditions. So those numbers or permission or condition, you can say threshold. So there is a threshold value on which basis our system decide, hey, the threshold can be based on the factors such as a number of failure requests, or latency of requests, or combine of both. So this number we can come. Hey, let's say I get number of request one, request two, request three. If three requests fail, that means this system can understand. Hey, somehow this system have some problem. Let's stop sending further request. So this is the maybe failure count. Hey, so you have a threshold maybe failure count. Threshold might be response your response time or latency. Let's key you call one API and you get a very slow response. Next, more slow. Next, more slow. That means you cannot say consecutive three, four or five requests go to more than expected response time. Then you can say, hey, now this machines is not so quickly responsive. They have some maybe more data, some in background process, something happened. So somehow the whatever the request come from here, we have to stop. So that is decision taken by to the system. The threshold make a very important role where our system going to decide when on the faulty node I am going to stop sending a request, and when I am going to resume start sending a request. So threshold is the key concept in the circuit breaker. So let's another, and there are some states. The circuit breaker can be in the following three states. So there are situations, means that means sometimes, hey, you decide I have to send the request. When you can decide I am not going to the send request, and again when you decide, let's say I am going to the continue sending the request, because this is the faulty node. This is a faulty node, and our circuit breaker is decide, hey, let's send the request, and when decide, no, I'm not going to send the request, and when again they decide, hey, let's say I'm going to the send request. So this is this condition or situation determined as a base of the state of this machine. Okay, so on the microservice or the component right now. So these are the possible three states, you can say. One is the closed states, open states, and your half open state. So similarly, look like in the case of might be in the engineering and the electrical science, there is a concept of, let's this is the once power supply going on, this is the some kind of circuit breaker, and again, so if you want to allow or you want to disallow, going to somehow you break the circuit, hey, this is the break the circuit, and so the power supply is not go on the particular units. So somehow if this circuit is joined, that means the request is going to flow, power is going to flow. If the request is somehow closed, that means the current, yes, supply is not going to the particular request. So similarly here, this our patterns decide on the basis of state. There are some closed state, open state, and half closed state. So let's get now, the circuit breaker is closed and the requests are allowed to pass through the service. So whenever this request is a close, state is in close means they are joined. This means request is going to the pass to the service. And when circuit break is open, the requests are blocked for reaching to the service. Now this state is open. This means there is no communication, no client connected. That means this is the circuit breaker is open. Open means the request is not going to forward to the respected service. And one is the half open state. That means the circuit break is a half open state when the limit the number of requests are allowed to pass through the service to test the availability. Okay, and one is the condition where your half open. That means they have some attempt condition. Let's we say, hey, request one, two, three. You already configure after three attempts. I am going to again try and check this node is repaired or access or not. If still they are properly respond and not responding, then it's again they wait for the next retry. Again after some requests, again they try, maybe after some timeout, yeah, after some delay, maybe sequential delay or maybe exponential delay. You have to define some condition on which basis this half open states are going to try to test, hey, this faulty nodes is now ready to respond or still we have to wait, because objective of circuit breaker is block the request until the faulty node is not recover, not in a good state where they can respond it. So one way decide is the faulty nodes, yeah, stop the forwarding request to the server. But after some period of times, we have to again test, hey, this node is available and repaired. So those testings, checking for resuming, one states are stopping. This is done. Your circuit is open. That means you can stop. Circuit is closed. That you can send. But how restart again? Resend on the basis of some condition, maybe multiple attempt, retry attempt, right? So these are the basics state where our circuit breakers decides when we are going to continue the request on the fault node. And when half a state also defines somehow the some timeout. But how much times we are going to stop sending request to the particular microservices, right? So circuit breaker has a timeout value determine how long it should be wait before attempting send to request to the service. So somehow we have to decide, hey, some maximum timeout, hey, let's give it try 5 minutes, and after 5 minutes you can try. So somehow the timeout is also the way, the time period when our circuit breaker is still waiting to send the next request to validate if the our fault node is ready for response or not. So in this architecture point of view of the circuit breaker, this is very simple, and they have only three components like our client and our you can say server service, a microservice, and one is the your circuit breaker components. Request come and there are some condition when they are allowed, when they are not allowed. So okay, so this is the some condition here decide, hey, I am blocking this request or allowing this request, let's retry. Okay, so these all three states are maintained by your circuit breaker. This is the client means this is microservice 1 and microservice 2. Both are communicated to each other. If everything fine, circuit breaker is by default circuit breaker is closed. When a circuit is breaker is closed, that means they are joint and call is happening by a circuit breaker. If something, and this circuit breaker is a responsibility to identify when I am going to open the circuit, yeah, when I am going to close the circuit, when I am going to the half closed circuit. So these two microservices have not do anything. All these solutions of the Cascade failure is taken care by your circuit breaker module or component or code we are going to talk. Okay, so from the microservice point of view, you are not going to do any kind of specific changes. Okay, there are some configuration required where we are going to the configure, hey, this microservice we are going to integrate this circuit breaker because they are going to talk to here. So this microservice required the configurations of this circuit breaker. So they are requested, hey, you before calling this, all the call go or via through circuit breaker, right? So these are the simple three component come in the designs of a circuit breaker. A client is an application that make request to the service, maybe microservice, maybe component. Service is the component that provide the service functionality requested by the client or microservice, and circuit breaker is the main component that's monitor the service and make decision about whether the request going to allow to the for do next service components are stop or check. Everything taken care by your circuit breaker components. So these are the same pictorial representation of these designs. Like the circuit breaker is always work on this three state. Your closed states. If your circuit breaker is closed, that means all the requests are successfully passed. All these things is success. Means the requests are properly our node or microservice is very healthy. They work properly. Anytime particular we have to decide some threshold because here our circuit breaker, no, this is a threshold. If our application is responding very slow, yeah, consequently three yeah, five requests are going to the fail, or we are not very response is very delay. So those, if something some threshold reach, then our circuit breaker state going to the close. That means now, whatever the request come, they are not going to call to the microservice. We have to wait. And once they are going to the open circuit breaker, that means all the requests, no request going to forward to the faulty node. Okay, but wait the timeout. There is a timeout concept. Here there is a threshold. First, our key concept of a threshold. Threshold decide when I am going to stop my circuit so that we are going to stop sending requests to the respective client or to the server. A timeout is the now our circuit is open. That means no request go to the our server. That means after some timeout, they are timeout. Whenever wait, once timeout is over, they are going to our half open state. Half open state again going to try. Hey, check the particular microservice is responsive, is repaired, is working or not. If working, that's a green. Hey, let's now close the circuit and close the circuit, and now all the requests going to successfully forwarded to the between the microservices. But might be still half circle decide no, still microservice is not responding, then still they are going to, hey, failure. That means still you can open your circuit because our node is not healthy, not prepared. So again, next till timeout, this circuit is going to open. Circuit is open means our circuit breaker is not allowed to call pass through the service. So these are the basics way the way these circuit breaker design patterns are implemented. Okay. Similarly, here API call, we have a concept of the retry. Similar, you can implement the retry, first API call attempt, or maybe halt, or half, and again try failure. If failure, then again retry. There is a concept of retry. You can also implement. Okay, so let's talk one simple example. So good case. Okay. Suppose we have a payment gateway service that called e-commerce application. So this is our payment gateway, and this is my any e-commerce platforms your application. So whenever you are selecting any product buying, surely once you are going to the buy, finally they are going to the call the payment microservice, and payment gateway are again going to finally lots of activity payment gateway have to do. Payment gateway are going to validate accounts. Payment gateway generally are going to maybe you there are two-way payment gateway. Payment gateway can be you can directly implement from the respective bank, or nowadays we are using the actual payment services like Stripe or PayPal. Just we request to the PayPal, and PayPal's are verified your account validity, everything, and all transactions happen, then they respond. So might be some because these are third-party services, might be third-party service delay, not responding. So anything's happen, right? Maybe your some maintenance service going on third party payment system. So those scenario, if the payment gateway service is not responding, might be case where your payment service is not responding, then e-commerce application will try to request multiple times, causing the cascading failure. Again, if this microservice, because lots of requests purchase order going on, and all requests again go in this, again go in this, again go in this, so that is due to that the multiple failure can be happen. So to prevent this, surely we have to implement their circuit breaker that monitor the payment gateway service and detect when it is not responding. So between the whenever this platform going to the call payment, our platform e-commerce platform going to the call payment service. So there is a circuit breaker. Circuit breaker is going to decide and monitor the payment gateway status, and then decide, hey, the particular failure or slow responsiveness, something happened. If the circuit breaker detects something, it will open, it will go to the open, means the prevent further request go to the payment gateway until the services recover are available. So, and internally they have a threshold on which basis they are going to the open circuit, so that the request is not going to forward. And after some timeout, once timeout done, again circuit breaker in the half open, they are going to the test. Hey, payment gateway service is open, working or not? It's still not working. It still say, hey, circuit breaker would be still open. There is a no call forward to the payment service. And once again a timeout reach, again our half open state going to the try to the payment service is properly responding, it's everything health is okay, then payment service half state say, hey, let's close the circuit is closed. That means now all the requests from the platform, uh, e-commerce platform call goes to the payment gateway, and payment gateway is now going to properly responsive. So the many use cases where you have to ensure the circuit breaker implements those services very don't want to further impact due to that scenario. So these are some use cases where you have to think, hey, I am going to use implement this circuit breaker. Surely, as mentioned, the preventing cascade failure. This means ki if one node is fault, due to that I'm not want this node also going to the faulty. Due to that, I'm not going to say this node also become faulty. Due to that, I'm not going to say this node also become faulty. This is known as a cascade failure. If something problem, stop all the call going through here. Let's keep rest all other services must be run as expected, right? The circuit breaker is prevent the cascade failure by detecting when the service is not responding and preventing further requests from being sent to it. Surely improve the system resilience. Circuit breaker improve the system resilience by allow the system recover from the failure more quickly. Here our we have a concept of half open. After some timeout, they are going to the check. Hey, this system is recover, fault is done, fixed. Then they are continue. So the automatically system going to normal. and this is also ensure that the reducing latency, because due to the system failure, application is not responding, so the customer also feel very low responsive. If we are giving the proper, hey, this service is currently down and this model is not working properly, dummy response or alternative response, or maybe if this is another way, this is a very critical component, so we have some alternatives gateway available. Hey, so I'm not going to by this will call route to the different gateway, yeah, alternative service, master slave. So here you can say lots of options we have available. Let's say this microservice is calling this microservice, and due to the failure, connection is the here open, that no call going to the here. Then alternative, what the you have to respond to the customer. So here multiple options we have to respond, hey, the particular service down, or again, hey, the particular dummy response, as of now we note your request and we'll do further action. Next, no, I have alternative high, I have skills as to one system down, let's open another system. If this system is down, our load balancer or our circuit router circuit I decide let's go to the different path, let's go to the different path. So we have multiple solution, but one solution we have to, circuit breaker say just wait for a couple of, maybe there is very small timeout, maybe some someone restarted machine, or someone going to upgrade happen maybe after 2 minutes or 3 minutes 5 minutes, system can be recovered. Okay, so let's retry instead of going to start new services, new service. Then after, still let's try couple of times, let's give attempt, I am going to every 5 minutes I am try to 10 times, still after 10 times there is no such thing happens, surely I am going to recover the new node. So we have a lots of alternative option here, but circuit breaker say let's just find out, at least we know, hey, there is a problem, stop sending request to the faulty node, and those requests you can, for responding customer you can respond maybe alternative response, alternative path, different route gateway, different payment gateway, we have to implement some action. And as you mentioned, as a fault scenario, circuit breaker can be used to detect the preventing cascading failure in the distributed networks, and also load shedding. Hey, if we are circuit breaker also can be used to set the load from the service that experiencing high traffic to the construction. So this circuit breaker also have to decide, hey, which particular microservice are getting a high volume, then the load can be distributed to the different service, load can be distributed to the different service, or load can be to the stop or sending to the here. The circuit breaker can do the multiple roles here. So maybe distributing load or requesting the request to the different node, stop sending request to the faulty slow or low responsive applications or modules. So if talk about the benefits, surely circuit breaker help improve our fault tolerance scenario. Fault tolerance scenario, that means in the distributed microservice environment, multiple microservices are working. If some node is not responding or very slow or some fault happen, so who is going to detect what the next course action item would be? So here circuit breaker else used to detect so those the scenario and tell, hey, now the request is going to route to the new instance of the same microservice, or already some instances running, call divert to the different node. Okay, so here also reduce latency I discussed, because the uh, detecting high latency in the service, circuit breaker can prevent the request from being sent service until become it's available. And this is also ensure that this system is always available. If something, some node is very heavy load responding, we have a detect at least and make the alternative solution available, so that our system can be available for the managing the fault. And the good part is that whatever the concept we discuss, the circuit breaker is a component. So as a system engineer, we are not going to implement this algorithm, this concept by yourself. good option already. All mostly all the application frameworks and technology offer this solution. So we should aware, hey, for this scenario I am going to implement circuit breaker design patterns. To implementing, we have to just integrate. We have to use the particular technology which is already available. Okay, so these technology are already implemented. We have to just configure and use them. Like Hystrix is a Java-based library. Just you configure, hey, this micro service is calling to this microservice, and I want to ensure that they can monitor and check the health of this. So we can just configure, hey, here I want to implement circuit breaker, and what are the alternative path, what are the methods, everything you can configure. So nowadays the latest you can say you can use this resilience 4J. This is the newest way and very very popular you can say framework Java library available for making our system is more resilient. Means more you can say find out the particular nodes which are not responding, which is very slow, with faulty nodes, and take next action. Okay, what the action would be. And even the Akka is also one of very very good Scala library that the concurrent and distributed system that ensure that they can maintain the your fault tolerant system. Istio is the one of the service-based platform which also offer built-in circuit breaker concept for you. If you are in the for is of popular open source library for building the .NET applications, where this circuit breaker is already implemented. So, as a system design engineer, excuse me, everything we are not going to implement by self, designing, writing code, everything. Instead, we should aware, hey, this is my system requirement, this is the situation, this is the scenario, and this is the scenario where I'm going to use the circuit breaker design patterns or approach, and the solution already technology offer us. We should aware and we should just integrate. These are the library. Just integrate your library and just little bit configuration required. You just mention the time. You just mention the what is the timeout, what is the threshold, what is the alternative path, when we can try it, when we can stop, and after some configuration, these library work on the behalf of you and meet the your requirement to handling fault and making your system more resilient. Okay, so be aware for this situation, this technology available, and this situation technically what we know, right? And even these kind of systems, mostly all the famous distributed systems already implemented. Talk about the Netflix already use a circuit breaker pattern to detect and preventing the cascading failure in the system. Amazon already using the circuit breaker pattern to detect and prevent high latency in their services. Google also is a circuit breaker pattern to detect and prevent cascading failure in the distribution system. So major all the Google, Microsoft, all the big player in the tech industries are already implemented circuit breaker pattern. They are not specifically circuit breaker. Already they have inbuilt, like you talk about service mesh, Istio, they are the bigger technology. They already implemented. They are already taken care. If you talk about the cloud service provider already taken care the fault tolerance, detecting your system failure. So these are the some concept with respect to our circuit breaker. The circuit breaker is the one of the technique, you can say one of the approach patterns in the distributed environment where your multiple microservice, multiple components are meet the customer requirement, meets the customer requirement, meets all the customer requirement. They are maybe interconnected, calling to each other, and maybe calling some third party services, and maybe any components or any microservices any times might be go unhealthy state. So if this microservice become on a unhealthy states, they are not properly responding, then we have to take decision. So these circuit breaker patterns help us to detect and find out, hey, the particular node is properly responding, properly healthy, there is no problem. If something problem, they automatically detects, and they detect, then they can take next action. They can say, hey, this system may be down, this system not responding. Let's spawn the new services, dummy response, or forward to the next microservices. So this action we can take. At least circuit breaker know, find out, hey, in the thousands, hundreds of microservices deployed in the Netflix, you can talk about hundred microservices are deployed. So these are automatically detects which node, which I'm going to the call, I'm going to the communicate, that are healthy, or responsiveness or not. Something irresponsive, something not responding, unhealthy, they can detect and forward request to maybe next action. Next action can be multiple. Okay, just retry, just can be route call to the alternative sleep to the master, or some duplicate node or replica node. So multiple action would be, but at least here circuit breaker help us in our system automatically detect the fault node. Fault node can be shut down, can be restart, can be very low responsiveness, can be very not so responsive, might be they are stuck somewhere. So all are the signal of your unhealthy node. So circuit breaker pattern help us to automatically detect healthy node in my distributed system. So hope this information is give you some little bit idea about the circuit breaker patterns. Thank you.